Welcome back. Hope you had a wonderful weekend and you have done your test very well. So, hope the revision helped you to perform well in your tests. Next, we'll be continuing our Wednesday's class. In Wednesday, we had completed with insertion, that is, insertion of a node as the first node, the last node, or anywhere in the given anywhere in between. I can say anywhere in between the linked list I can insert a node, and I can insert the node as the first node, that is the new node created can be the first node in already an existing linked list. I can make it as the last node, which is very easy because during creation also we do the same thing, that is one first node, the one I create the first would be the first node, the next would get attached to the first node after the first node, not before that. So the something very similar wherein you attach a node to the last of the list, and then anywhere in between, like you want to have this node inserted between two nodes, you can also do that. We did the algorithm as well as the function code module I have written for all the three. Next is the deletion of a node. Deleting. Like whenever I say linked list, it's dynamically allocating and deallocating memory. That is why to begin with, I won't specify how many nodes would be there in my list, because beforehand it is not an array. Therein you need to specify the size of it. As and when you need to add an element, you go on creating a node. When I say creating a node, you would be dynamically allocating memory for it and store the data and then just attach it to the list. That is why the nodes are scattered throughout your memory space, because you will not get contiguous memory locations. It was not created at the same time during compile time. You will do it during runtime. So as and when you create a node and allocate memory wherever the available space, that many bytes of space is available, that is given during, that is allocated during the runtime. So every node will have a pointer, two parts. One is the information part, which would store the information of the node, and then the link part, which would point to the next node in the list. I'm talking about the singly linked list over here, and that too singly linked list, not even single circular linked list. So that the each node will have the information about the next node in the list. So they are logically linked to one another, and we can traverse using the link path, right? And how do I say which is the first node in the list? Because I should know like which is, where is the list starting and where is the list ending. So first node in the list, there's a pointer. I can have start, first pointer, head, whichever, and I have used head everywhere, so I would be continuing to refer that. Head is also a pointer which would be pointing to a structure node, and head will always point to the first node in the list. If there are no nodes in the list, that is my linked list is empty, head would be pointing to null. So wherever, to whichever node head points to would be my first node in the list, and then the last node's link part would be pointing to null. That is how I identify the last node in my list. That is the node which link part, whose link part is pointing to null, is the last node in my list. This is how I know I have come to the end of the list. When you're traversing the list, normally you traverse the list from head to the end, getting it? And that is why the first node, it is not by subscript value, so I would start from 1 2 3 4, not 0 1 2 3. Getting it? The node to which head is pointing to is my first node, and the link part of the last node would be pointing to null. So this is how I know which is the beginning of my list and where the list ends in case of a single linked list. And each node will have the information about its next immediate node. It will not have any information about the previous node, because there is only one link part which points, one pointer which points to the next node. You are not able to point to the previous node in a single linked list. In a doubly linked list you can do both, but then in a single linked list, each node will have the information about the immediate next node, so you can traverse it that way only in one direction, that is starting from head to the tail. You cannot traverse it in reverse direction. Getting it? Hopefully you've understood till now. And then I already have a list and I have created a new node. I can insert the new node into an existing list. I can insert it in the beginning, like make it the first node in the list or end of list. Adding it to the end of list is very similar to creation of linked list, where I go create the first one and check. I create a node and check whether it is the first one. How will I know that? If head is null, that node would be the first one. Then I would make head point to the first node, whatever I have created, and when I create, I would have taken in the information part and stored it, and I would have made the link part null. So that when there is only one node, that would be the first node as well as the last node. So head will also point to that node, and the link part also would be pointing to null. So next node, if I want to attach, I would be attaching after the first node. That is, as and when I go on creating new nodes, I will go on attaching it to the end of the list. So when you create linked list, this attaching or inserting a node at the end of the list is very similar to creation of a linked list. Here only thing is I am not going on creating new nodes. Only thing I do is I will create a node, I will traverse it till the end. How do I know it is the end? Where the link part of the node would be null, and then I make that link part instead of null point to the new node, so automatically it gets attached. Also, I can insert it anywhere in between. We did all the three, wherein beginning, end, as well as the in between. The insertion was done. I showed you the algorithm as well as I explained it along with the diagram, and then I gave you the code module. Now in today's class, we'll be doing the deletion of a node. Deleting is something freeing the memory so that it can be reused. When I can dynamically allocate memory, I should be able to dynamically deallocate memory so that it can be reused as the until I would be using it until I need it, but once I don't need it, I can free the memory so that it can be reused. So deleting a node, again, the deletion can also happen. It can be the first node, it can be the last node, or anywhere in between. You can delete a node which happens to be the first node. You can delete a node which is the last node, as well as anywhere in between. This is also possible. In today's class, we'll be doing deletion of the first node. I will teach you, I'll write the algorithm and I'll explain it with a diagram, and then I will write a function module which would be doing this. Then we will do the deletion of the last node, wherein I would again write you the algorithm. I'll explain it to you, as well as we will write the code module, and at a given position it is like you know what is given position, right? But then it is not there. I don't think it's there in your syllabus, so I will not be writing the algorithm for it. But then I'll just double check it again. If it is there, we can do that also. So we'll start with deletion of a node which happens to be the first node in the list. So whenever I say deletion, to delete something, it should be present, right? If it is not there, then you cannot delete. Yeah. So first thing you need to know is whether there are some nodes in the list. At least one node should be there in your linked list to delete. If there are no nodes in your linked list, that is, your linked list is empty, you cannot delete. If you're trying to delete from an empty node, what is that condition called? That condition is called underflow condition. What is an underflow condition? Wherein you're trying to delete a node from an empty list. The first thing, whether it's the first node, the last node, or given at a location, at a given node, deleting a node at a given position, whenever deletion is there, you have to check at least there should be one node in your linked list to delete. You cannot delete from an empty list. That is, there should be no underflow condition. You have to check for an underflow condition. If that is not true, then only you can proceed with the deletion. So we can here the diagram shows we can easily delete the first node. How do I do that? See, head, or here they have given you start, but wherein I would be referring to it as head. Set name does not matter. Only thing is it should be a pointer which points to the structure node. While writing the code, you should have declared it, and whatever name you declare it as start, you declare it as head, or you declare it as first pointer, whatever you want, and a proper acceptable identifier name, syntactically acceptable identifier name should be there, where you should have declared it as a pointer type, which would be pointing to a structure node. So, and then when you create the list, the node with that pointer should be pointing to the first node. Here I have start. When I write my algorithm, I will be using head. So start would be pointing to the first node. That is how I'll know which is the first node, and I need to delete it. So how do I do it? See, once I delete the first node, logically the second node will become the first node. Yes, because when the first node goes, the second one would become the first. So once it becomes the first, how do you do that? How do you ensure that the second node is the first node? Once you take this out, by making the start point to the second node, so automatically that becomes the first node, and deallocate memory for the first node, so it goes out and it can be reused, and the second node will become the first node in the list. Yeah, now please go through the statement again, then we can start writing the algorithm for that. So here I already have a linked list, right? I have how many nodes here? 1, 2, 3 and 4. 4 nodes are there, and I'm not creating any new node because I'm deleting an existing node. When I'm deleting a node, I don't have to create anything. So dynamic creation or allocating memory during runtime, I'm not doing it here. I'm just deallocating memory of the node, which can be wherein you can reuse it, right? So how many nodes are there? I have 4 nodes. How do I know which is the first node? The information part of the first node is 67, and the link part is pointing to the next node. The second node is pointing to the third, and the fourth node's link part is pointing to null. So the fourth node is the last node in the list, and head is the pointer which points to the first node. So I know this is my first node. If I delete it, then automatically the node whose information part is 56. So head should point here, right? And this becomes my first node, and then I will be the other two remains the same because I'm not going to change anything, only I'm just taking out the first node. So I only logical thing is I need to make head point to this and then free this node so that it can be reused. And before freeing, I need to store the information part in a variable so that I can retrieve what was there in the information part of it. Otherwise, if you free that without noting it down, you will not be able to get back whatever data was stored in the information part. So just write down the data and then free the node so that it can be reused, and then I will be left with 3 nodes in the list. The last node again is pointing to null. This remains the last node. There will be no changes in anything. Only thing is I'll make the head. The second node becomes the first node when I delete the first node. So head should point to the second node instead of the first node. This is the procedure. Before that, I need to check for the underflow condition, whether there are any loads in the list or not, or whether my node is empty or not. If my node is empty, I need to give information to the user stating that underflow condition, there are no nodes to delete. Otherwise, you should be able to delete the first node. Getting it? So please write down the statement of the algorithm for deletion of a first node. Deletion of the first node. So deletion of the first node. I'm going to delete the first node in the list. Please Write down the statement of it along with me. Let list be a linked list stored in memory. Okay, it deletes first node from the linked list. Head gives the address of the first node. So this is the statement. Let list be a linked list stored in memory, which means that it is already there. It deletes the first node from the linked list. I'm going to delete the first node. This algorithm, when I say it, it refers to the algorithm. This algorithm, that is, it deletes the first node from the linked list. Head gives the address of the first node. We can see in the picture also, diagram also, head is pointing to the first node. So it does nothing but the algorithm deletes the first node from the linked list. Head gives the address of the first node. So step 1, what I should do is the list empty. Check for the underflow condition. How do I do that? When there are no nodes in my list, head won't be pointing to null. Otherwise, it would point to the first node, right? So, if head is equal to null, display underflow. Exit. Then it's end of if. Yeah. This is the first step. That is the list empty? Check for the underflow condition. How do I check? UNDR. Underflow, right? Check for the underflow condition. If head is null, then there are no nodes in my list. Only when my list is empty, head would be null. Otherwise, the head would be pointing to the first node in the list. So if head is equal to null, display underflow, exit and end if. This is the first step. If this is not true, that is, there is no underflow condition, there are nodes in my list, what I have to do? Step what will be my step 2? Initialize pointer variable current pointer. Initialize pointer variable current pointer. Okay. What would I be initializing it to? I will be initializing it to head. Okay. After that, step 3, delete first node. How will I be doing that? Head is equal to link of current pointer. Yeah, head is equal to link of current pointer. I'll explain this. You please note it down. Step 4, return deleted node to the avail list, that is availability list, so that it is available, the memory space is available. Free current pointer exit. See, storing the information part, I will do it in the program. So this is the procedure. Algorithm is normally the procedure what you need to follow. Please note it down. So hopefully I've finished writing it. Please write it down. I would want you to write it along with me. Another 2 minutes I would be giving you to write it down. So the first step, what am I doing here, is the list empty. Check for the underflow condition if head is equal to null. Here is head null? No, it is not null. It is pointing to the first node. So this condition, the if is not true. Then what am I going to do? I'm going to the step 2. Initialize the pointer variable current pointer. What am I doing? I am making the current pointer point to head. So when I say making the current pointer point to head, where is head pointing to? It is pointing here. So I need to make the current pointer also point there. Yeah. So current pointer is also pointing to head. You can see here current pointer is pointing to head. That is the first node. After that, what am I doing? Delete the first node. That is, head is equal to link of current pointer. The next step, first step is make the current pointer point to head. Head is pointing to the first node. So I am making the current pointer also point to the first node. After that, current, what am I doing? I am making head is equal to link of current pointer. Next step. Okay. So current pointer is pointing here, right? What is the link of current pointer pointing to? The link of current pointer is pointing here. Yes, as you can see, current pointer is pointing here. The link head is equal to link of current pointer. So where is the current pointer link pointing to? It is pointing here. So where should head point now? Head should point to this node, right? So yeah, this is correct. Now, where is current pointer pointing to? I am not moving the current pointer here. So, current pointer will be pointing to this node only. Only thing is I made head point to the link of current pointer. That is, head is pointing here now. After that, what I need to do? After that, free current pointer. What do you mean by free? The free is a function in C++ which deallocates a block of memory previously allocated during runtime. Getting it? That is, free is a function in C++ that deallocates a block of memory which is previously allocated during runtime. So, free current pointer will take out this from the list. That is, it will delete this node from the list. Free current pointer is pointing to this node. Free is a function in C++ which deallocates a block of memory previously allocated during runtime. So, this was allocated during runtime. It deallocates and puts in the availability list or the heap or the free pool. So, it will go back and it can be allocated again. Getting it? And where is head pointing to? Head pointing to the first node in the list. Yes, head is pointing to the first node because the second node becomes the first node in the list. When I free this arrow, everything, the entire thing goes. And head would be pointing to the first node. Hopefully you have understood this. Yeah. Now we'll write down the function to delete a node at the beginning of the linked list. Function to delete a node at linked list. Please make a note. Int. Int means I am going to return an integer value. The return type of the function is int, even if you don't specify anything. Delete from the beginning. So this is int DELBEG is I'm going to delete. That is the name of the function. It's not a keyword. It's a user defined name. I have given it. I'm going to delete it from the beginning. So the name given is DELBEG. Then after that, first I need to create a pointer, right? Node star. So current pointer is a pointer which is going to point to a structure node. Head is already there, so I'm not going to create head here, because in an already existing list, head would be there and it would be pointing to the first node. If it is empty also, head would be null. So in either cases, I need not declare head. Here also, if I had a total program, I would have declared current pointer there, then I need not have to do it. But then in this module, I will be doing it. Getting it? Then after that, to store the deleted information part, before deleting, to store information part of the node which you're going to delete, I'm going to have an integer variable, because the information part is integer over here. Whatever is the data type of the information part, declare a variable of the same type. Then I need to check for the underflow condition. Head double equal to, since this is a program, then I need to write double equal to here, because you need to use a relational operator, not an assignment operator. What does the assignment, that is a single equal to, do? It will assign the value of LHS. It will assign the value of RHS to LHS, whereas a relational operator compares the LHS and the RHS and gives you a true or a false value. So for if I need to have the true or a false value, if this condition is true, then only go inside the if block gets executed, otherwise no. So if head is double equal to null, it means that there are no nodes in my list. So I need to say cout ender. What will I say? Deletion not possible. List empty. List empty. Underflow. Okay. So deletion not possible, list empty. Then I will say endl exit 0 ended. Otherwise, if it is not true, what I should do? I should make is equal to head, right? Current pointer is equal to head. Then after that, I need to write the information part. That is the node which I am deleting. I need to first copy the information part in the variable declared. So how will I do that? ELE is equal to current pointers info, right? After that, I have to delete the first node. How do I do that? First, I need to make head point to the link of the current pointer. Link of the current pointer would be pointing to the second node in the list, because current pointer and head at present are pointing to the first node. So, is equal to yeah. is equal to link of current pointer. After that, free current pointer. Return ELE. This is the end of my function. What did I do? First I return ELE. Yeah, this function is going to return an integer value. I have already said that. So what I am going to do? First I am declaring a pointer called current pointer, which is going to point to a node. Then I am also having an integer variable used for why I would need that, which is required for storing the information part of the node, which is to be deleted, and I'm going to return it to the calling function. Then I need to check for the underflow condition, that is, if head is equal to null, then deletion not possible, I am going to exit. If this is not true, I'm not writing else here because after exit it will not come and execute. That is why I'm not writing else here. If that does not get true, if it is not true, then the control will not go inside the if at all, and it will start executing after the if. This exit, it is not a capital one, it has to be lowercase. So then current pointer is equal to head. I am going to assign the current pointer, that is our head is pointing to the first, so automatically current pointer would also point to the first node. ELE is equal to current pointers info. Why am I using an arrow here, not a dot? Because it is a pointer. Current pointer is a pointer. When you are having a pointer, you need to use an arrow to access the variables inside the structure rather than the dot. Otherwise, you will be using dot. So ELE is equal to current pointer info. Then I say head is equal to the link of the current pointer. The link of the current pointer would be pointing to the second node. So head would point to the second node, and I'm going to free current pointer. The free function in C++ deallocates a block of memory previously allocated during runtime. Okay, it does not change the value of the pointer, that is, it still points to the same memory location. After that, free current pointer. Then I am going to return the element to the calling function. This is the function for deleting a node in the beginning. Please make a note of it. So we finished the code module or the function to delete the first node. Now we'll be doing deletion of the node at the end, that is deletion of the last node. How do I know it as the last node? Because the link part of that would be pointing to null. So I need to delete the node whose link part is pointing to null, because that happens to be the last node. When I delete the last node, the node before that would become the last node, right? Because if I delete, there are 10 nodes in my list, and if I delete the 10th node, then the 9th node should become the last node. So the thing is, first I have to check for the underflow condition. I need to traverse till the last node, delete it, and then I need to make the previous node the last node by making the link part of it point to null. This is the thing. So deleting the node from the end. Like, how do I do that? See, with one pointer, I cannot do it because I need to make note of the last node as well as the last but one node. Because once I remove the last node, I need to have the last but one node, right? To make it the last node. So how do I do that? Because from the last node I cannot access the previous node because I can access only the node next to it. So you should have two pointers wherein both would be starting from the first node and you're traversing the list until one of the pointers reaches the last node. For example, if I have P1 and P2 are two pointers, I would start from the start like the first node and I would traverse the list until P2 reaches the last node. So when P2 reaches the last node, P1 should be placed in the node prior to that. That is one node before that. P1 should be pointing to a node which is last but one node. So when I free P2, I should be able to get where is the last but one node, like because you cannot leave it as it is. The last but one node at present before deleting the last node would be pointing to the last node in the list. So when I take out the last node, then the last but one node should become the last node. How do I make it? By making the link part of it point to null. So if you want to do that, then you need to have the location of the last but one node. For that reason, I will have two pointers, like one would be pointing to the last node and the other would be pointing to the last but one node. So when I free the last node, I need to make the link part of the last but one node point to null. This is the thing. Like first thing what I need to do, I need to check for the underflow condition, that is whether the list is empty or not. If the list is empty, I should say that I cannot delete anything. If the list is not empty, then I should be able to traverse the list, right? For that I would need two pointers because I need to keep track of the last node as well as the last but one node after deletion of the last node, which would become the last node of the list, right? So I would have here in this diagram, start as a pointer which points to the first node and P1 and P2 are the pointers which I am going to use for traversal. Starting from the first node, I would be traversing when P2 reaches the last node. How do I know that? Because the link part of the last node is null. P1 should be pointing to the last but one node, that is one node prior to the last node. So once I delete the node or once I delete or free the node to which P2 is pointing to, then the link part of P1 should become null, which automatically makes it the last node in the list. This is the procedure what I need to do. I will write the algorithm with the diagram. I will explain it to you so that it will be easy for you to understand. Then after that we will write the function module for doing the same. Please have a look at the diagram now. So here let me write it. So this was the previous question. What I did, let me delete it. Deletion of the first node, hopefully you have understood. Deletion of the node at the end, that is the function load. Let me write the algorithm for it. First, we'll start with the algorithm and then I will write the code module, that is the function for doing the same. Deletion of the last node in the linked list. So please make a note of the algorithm statement. Let list be a linked list stored in memory. It decides, it deletes. What does it mean here? It means the algorithm. Okay. It deletes first node from the linked list. Sorry, it deletes the last node from the linked list. From deletes the last node from the linked list. Head gives the address of the first node. Yes. It gives the address of the first node. Current pointer is a pointer which is pointing to the current node of the list. Pref pointer is a pointer which pointing to the previous node of the current node. Okay. So there are, what is the question? Please make a note of this. Let list be a linked list stored in memory. It means the algorithm deletes the last node from the linked list. Head gives the address of the first node. Yes, you should know which is the first node in order to traverse. And current pointer is a pointer which is pointing to the current node of the list. Wherever current node of the list, when you traverse whichever node, current node of the list it will point to. And pref pointer, or I can say previous pointer, is a pointer which is pointing to the previous node of the current node. That is, previous pointer is pointing to a node which is one behind the current node. That is, to which, suppose current pointer is pointing to the node number 5, then previous pointer would be pointing to node number 4. That is what it means. Please make a note of the algorithm statement, then we can proceed with the algorithm. So hopefully I have written down the statement. See here, what I have to do, head is pointing to the first node in the list. What is the first node? Wherein the information part is 67. So when you have to delete the last node, that is, which is the last node over here? The last node is where this is the last node, wherein the information part is 50. How do I know it is the last node? Because the link part of this is pointing to null, right? Then what I have to do is, one, I exit the loop. The current pointer should point to the last node and the previous pointer should point to this node, right? Because once I delete the last node, this node should become the last node. That is the thing. Like there are totally 4 nodes. I have deleted the last node. Last node is nothing but the information part of is 50 and the link is null. So the current pointer should point here. When the current pointer is pointing to the last node, the previous pointer should be pointing to the last but one node, because once I delete the last node, then this node, that is the one but previous node, right? Previous to the last node becomes the last node. So I should make the link part of it point to null. So that is the procedure. So you need to traverse from the node to which head is pointing to, and by the end, when you go out of the loop, the current pointer would be pointing to the last node, previous pointer would be pointing to the last but one node. You free the node or delete the node which is present, to which the current pointer is pointing to, after noting down the information part of it, and make the node to which the previous pointer is pointing to as the last node by making the link part as null. This is the thing. Before that, you need to check for the underflow condition. Fine, that is the thing what you need to do. But since it is a little bigger algorithm and it would take time, like I have around 7 to 8 minutes and I will not be able to complete that, and then I need to explain it also. So please make a note of the statement. We will continue with the algorithm in the next class, so that I will have more time to explain, write, and then write the code module of that. With that, we would be coming to the end of linked list. Then we have trees and graphs, wherein you don't have programming in that, but they are important for 1 markers and 3 markers, especially trees. We will be doing that. Please make a note of this statement and then today's homework question. Write a program to find the frequency of presence of an element in an array. So this is the first one. You need to write the program for that. The second one is write a program. Write a program to insert an element into an array at a given position. See, these two are very important programs. You need to learn this because this is the first 2 questions of part A in the lab, and it's a 100% question in the lab. You may get this, and once if you get this, they won't give you any change of programs. From last year they have stopped giving you change of programs, so you need to do this. And both the programs, the algorithm and the program, has been taught in detail in the class along with trace, and I have shown you the execution of this programs also. So I want you to, if you're not able to get it, I want you to go back, go through the class, because in some manuals they have given the declaration and the definition of the function inside the class, wherein for lab you need to write it, declare the function inside and write it outside. So what you need to do is, I have done it the same way. You need to go through the class, the data structures class only, wherein I had started with arrays. So arrays, the first program is the traversal example which I have taken. The second one is the insertion of an element, wherein I have taught you the trace, the program, as well as the algorithm for it. Algorithm is important for your theory as well as program is important for your lab. I want you to learn and write. Don't write it just for finishing your homework. You're learning and writing, which will help you because you would be completing the lab part. Like, see, lab of data structures, whatever questions are there, all of that I have written the program as well as I have shown you the execution of it. We have covered the lab part of data structures, whereas C++ lab part I have written and shown you the trace of it, not shown you the execution, wherein after data structures I will show you the execution of all the lab programs of C++, so that we would be completing the lab part also. Before, after that I would be starting with Boolean algebra. Before that we will be completing the lab syllabus also. Theoretically, like during the class hours I have finished the lab syllabus, but then execution of C++ I need to show you. Data structures I have shown you the execution of that also. So these two questions I want you to learn it and then write it on your own, or at least understand the algorithm. See, you don't have to mug up because mugging will not help you. Please try to understand the algorithm, the procedure, and write the code on your own, because you have learnt all the concepts, the class, the member functions, the data members, declaration of functions inside, writing it outside, creating objects, and how to call them. All these concepts have been taught, so you should be able to write it on your own. Please make a note of the homework question along with the question algorithm statement, and we'll be continuing the algorithm. Like, I'll write the algorithm to delete the last node and explain it to you in the next class. So hope you've understood today's class. Take care, stay safe, see you tomorrow. Bye bye.